So arithmetic sequence is basically when the difference between the numbers is the same. So the difference is constant. Okay, so this one 5, 7, 9, 11. The difference is +2. That's an arithmetic sequence. This one 12.5, 10, 7.55 goes down by 2.5. So that's also an arithmetic sequence. This one, the difference is not constant. So this is not arithmetic sequence. Okay. Actually, the second differences are 2. So maybe if you did GCSE, you will know that's a quadratic sequence, but don't worry about it. So for an arithmetic sequence, the differences between consecutive terms have to be the same, positive or negative. So the notation they use is over here. A is always the first term. D is the common difference. So that can be positive or negative. So for the first sequence, 5, 7, 9, 11, you'd say A equals 5, first term. The difference is +2, so you'd say the common difference, D equals 2. For the second sequence, the first term is 12.5, A is 12.5. It goes down by 2.5 constantly, so you'd say D is negative 2.5. Okay, so that's how you specify these two sequences with A and D. Nth term of a sequence. Okay, so notation, U1 is the symbol for the first term. Sometimes they use different letters, but usually it's U1, U2, U2, U3, U4. So the first term, U1, is A. The second term is A plus D. This is the general case. You add on the common difference. To get the third term, you add on another D. Get the fourth term, you add on another D. Okay, so that's the structure of an arithmetic sequence. You just add on the common difference, starting with the value of the first term, A. So if you continue that pattern, you see that the nth term is not A plus ND. The number of D's is always one less. A plus N minus 1D. That is the formula for the nth term of any arithmetic sequence. I think in the GCSE and the IFP, they give you the formula. For A level, I don't think they give it to you. So by plugging it in A and D, you can work out the nth term of any arithmetic sequence. Nth term, okay, so they've given you an arithmetic sequence, they've given you the nth term formula, write down the first 5 terms. All you need to do is work out U1 to U5. Okay, so the first term, you just work out 55, take away 2 times 1, which is equal to 53. U2, 55, plug in n equals 2. 55 take away 4 is 51. Okay, so it's pretty clear what's going on. You put n equal to 3, goes down by 2 again. Okay, so U4 will be 47, and U5, fifth term, will be 45. That's it. 99th term, you want to work out, put n equal to 99. Two times 99. That gives you minus 143. So that's the 99th term of the sequence. Okay, part C. Find the first term for which the sequence becomes negative. Okay, so you don't want to do it by trial and error. So the sequence is going down, so you want to know when it first becomes negative. So you want to know for what value of n does the sequence become negative? So the nth term is 55 minus 2n. So you get 2n greater than 55, which tells you that n is greater than 55 divided by 2. But remember, n has to be a positive whole number, the position in the sequence. So so the first term for when the sequence is negative is the 28th term. Find the first term. So you can say sequence becomes negative when n equals 28. So it has to be a positive number bigger than 27.5. Then you can calculate. It says find the first term, so you need to evaluate it when n equals 28. So i.e. 55 minus 2 times 28. 55 take away 56 equals minus 1. So minus 1 is the first negative term in the sequence, and that happens when n equals 28th term. Okay, here they want you to, you're told they're arithmetic sequences. So this is just applying the formula. So for this one, it goes up by definitely a equals 6, first term. The difference is positive 14. So the nth term will be, so the formula is a plus n minus 1d. So it's 6 plus n minus 1 times by d. Expand the brackets, 14n. 6 take away 14 is minus 8. So that's the nth term of the first one. Part B, first term is 101. It's going down by 7. So you need to write d as negative 7 because it's going down. Common difference. Then the formula is a plus n minus 1 times by d. Simplify it, you'll get minus 7n. 101 plus 7 is 108. So that's the nth term of that sequence. Is that easy? Is that foolproof? So you're given a formula un equals an plus b. So this is a linear expression. So whenever you have a linear expression, the sequence will turn out to be arithmetic anyway. So u3 equals 5. So when n equals 3, so you get two equations that you need to solve simultaneously. So if the third term is 5, that means 5 is equal to 3a plus b. So you just put n equal to 3, third term. Eighth term is 20. So when the eighth term is 20, all I've done is put n equals to 8. So find a and b, 15, 5a, a equals 3, first term equals 3. And this implies b equals minus 4. So then formula for this sequence would be 3n minus 4. Useful tip. If you've got an arithmetic sequence, u1, u2, u3, the difference between consecutive terms are the same. So if you need to find the value of d, the difference between the second and the first must also be equal to the difference between the third and the second, etc. So if you ever the consecutive differences between terms have to be the same. That's useful stuff for some of the questions.